In this video, I'm going to talk about the periodic table and certain properties of elements found in this table. So let's go over the first column, group 1A. In this group, you have elements such as hydrogen, lithium, sodium, potassium, rubidium, and so forth. Now, hydrogen is considered to be a nonmetal, but the ones below it, like lithium, sodium, and potassium, these are considered to be metals. They're known as the alkaline metals. They're very reactive. If you put them in water, they pretty much blow up. Now, each of these elements in this column has one valence electron. Metals, they like to give away electrons, and they tend to form positively charged ions, also known as cations. So lithium, sodium, potassium, as ions, they're going to form a +1 charge. Now, the next column is the group 2 elements. They include beryllium, magnesium, calcium, strontium, and even barium. So these are known as the alkaline earth metals. They have 2 valence electrons and they form ions with a +2 charge. The alkali metals, group 1, they're the most reactive metals that we know of. The alkaline earth metals, they're also reactive, but not as reactive as the alkaline metals. Then over here, we have the transition metals. I'm not going to write all of them, but some transition metals are reactive, others are not. They vary. But there are some common elements that you want to know, such as zinc, copper, Fe stands for iron, Ag is silver, Au is gold, Pt platinum, Hg mercury. So those are some common symbols that you want to be familiar with. Now we have other elements like boron, carbon, nitrogen, oxygen, fluorine, neon, helium, argon, krypton, aluminum, gallium, silicon, germanium, phosphorus, arsenic, antimony, tin, lead, sulfur, selenium, Te, chlorine, bromine, iodine, xenon, and so forth. Now, group 8, these are known as the noble gases. Helium has only 2 valence electrons. The first row elements, they can't have more than 2 electrons. Neon has 8 valence electrons. The noble gases are chemically inert. For the most part, they don't really react much, so they're very stable. The next group is the halogens, which include fluorine, chlorine, bromine, and iodine. These elements have 7 valence electrons. They're known as group 7A or group 17 on the periodic table, and they form -1 charges as ions. The halogens are very reactive. They're nonmetals, but they're extremely reactive. They're the most reactive nonmetals that we know of. The next column are the chalcogens. That's group 6A or group 16 of the periodic table, and they have 6 valence electrons, and they tend to form -2 charges. Nitrogen, phosphorus, arsenic, those elements have 5 valence electrons, and they typically form -3 charges. Boron, aluminum, gallium, they have 3 valence electrons, and they form +3 charged ions. Now, the next group in the middle that have carbon, silicon, germanium, they have 4 valence electrons, but their charges can vary. Carbon and silicon, they're typically, you don't really see them in an ionic form, but the elements in group 4, they can form +4 charges or +2 charges. A good example is tin and lead. Tin has 2 oxidation states. the +2 oxidation state and the +4 oxidation state. Lead is the same thing. It can be +2 or +4. And then you also have some other elements over here, which are known as the inner transition metals. The first row represents the lanthanides, and the second row is the actinides. Now, in the periodic table, sometimes you might see a line that looks like this. The elements that are very close to that line, they behave as metalloids. The elements on the far left, so basically this entire group here, that's the metals. Metals, they conduct heat and electricity. They're also malleable. They can be hammered into sheets, and they're ductile. They can be pulled into a wire. So you have metals. Metals like to give away electrons. So metals are electropositive. As they give away electrons, they form positive charges. Now the elements on the upper right side of the periodic table represent the nonmetals. The nonmetals do not conduct electricity. They're insulators. And they like to acquire electrons. The nonmetals are electronegative. As they acquire electrons, they gain negative charges. Fluorine is the most electronegative element on the periodic table. On the other side, below rubidium, you have cesium, and then below that, francium. Francium is one of the most electropositive metals. Francium really wants to give away an electron. Fluorine really wants to acquire an electron. So the two are opposite in their behavior. Now, along the red line, we have something called metalloids. Metalloids are like in between metals and nonmetals. They're not pure insulators like nonmetals, and they're not as good as metals in terms of electrical conductivity. Metals conduct electricity very, very well. Nonmetals do not conduct electricity at all. Metalloids, they conduct a small amount of electricity. Some of the most common metalloids that you'll see in chemistry are silicon and germanium. Whenever you shine light on a metalloid, or if you raise the temperature of a metalloid, the electrical conductivity goes up. If you increase the temperature of a metal, the electrical conductivity decreases. Metals become superconductors if you can cool them to a very low temperature, close to absolute zero. Now, another thing you need to know about the periodic table is the representative elements. The representative elements include the elements that are not transition metals. So, elements that are not in this block or the inner transition metals. Those are not representative elements. Everything else are known as representative elements. So group 1, group 2, group 13 to 18, or group 3A to 8A, those are known as representative elements. In the periodic table, there's two numbers that are important that you should know. So let's look at the symbol for fluorine, which is F. You'll see that there's two numbers. A number 9 on top and 19 below the element symbol. The smaller of the two numbers represents the atomic number, and the larger number is the average atomic mass. You could simply say atomic mass. The atomic number is always equal to the number of protons. So fluorine has 9 protons. The atomic mass represents the number of neutrons and protons. So fluorine has 9 protons, 10 neutrons. It adds up to 19. Let's consider an atom of lithium. Lithium has an atomic number of 3, and if we average the mass number, it's about 7. So the number of protons that it has is 3 protons. If you take the difference between 7 minus 3, if you subtract the mass number and the atomic number, you'll get the number of neutrons. Now, in an atom, the number of protons and electrons are the same. An atom is electrically neutral. So a lithium atom has 3 electrons. If you draw it, let's say this is the nucleus of the lithium atom. In the first shell, it holds 2 electrons, and in the second shell, it has 1 electron. The number of electrons in the outermost energy level represents the valence electrons. So lithium has a total of 3 electrons. It has 1 valence electron and 2 core electrons. The core electrons are the electrons that are inside of the atom. Now, within the nucleus of the atom, which is here, the protons and the neutrons exist in that location. So the 3 protons and 4 neutrons, they're inside the nucleus of the atom. That's where most of the atom's mass is located, is within that small, tiny region of the nucleus. The electrons are orbiting around the nucleus. Now, here's a question for you. You've learned from physics that like charges repel. If you put 2 positive charges next to each other, they're going to feel a force that's going to accelerate them away from each other. But if you put a positive and a negative charge next to each other, these two will experience a force of attraction. So the nucleus, which has protons, which contain positive charges, and neutrons, which are neutral, why don't the positive charges, why don't they move apart? Aren't these 2 charges repelling each other, so shouldn't they fly apart? It turns out that the electric force that wants to separate the protons is balanced by another force known as the strong nuclear force. There's another force that keeps the protons and the neutrons locked in together. Outside of that, we have the electrons, which are attracted to the protons. But the electrons are moving so fast around the atom, and the force of attraction between the electrons and the protons, it helps the electrons to stay in orbit around the nucleus. So those are some basic principles that you want to be familiar with in an atom. But let's work on some problems finding the number of electrons and protons and neutrons inside an atom. So keep this in mind. The number of protons is equal to the atomic number, and the number of neutrons is equal to the mass number minus the atomic number. The number of electrons within an atom is equal to the atomic number minus the charge. An atom is electrically neutral, so it doesn't have a charge, which means for atoms, protons and electrons are the same. But for an ion, which has a charge, the number of protons and electrons are unequal. Consider these 2 examples. Aluminum and the aluminum plus 3 ion. The atomic number of aluminum will always be 13, and the mass number is approximately 27. In the periodic table, the 13 is on top, but whenever you write an isotope of an element, that's elements with different mass numbers, but with the same number of protons or the same atomic number, typically is written this way. You have the atomic number on the bottom and the mass number on top. But don't let it confuse you. The smaller of the 2 is always the atomic number. The mass number is the larger of the 2 numbers. So how many protons does aluminum have? The number of protons will always equal the atomic number. To find the number of neutrons is the difference between the mass number and the atomic number. So it's 27 minus 13. So aluminum has 14 neutrons. Now the number of electrons will differ between an atom and an ion. The number of electrons is the atomic number minus the charge. An atom is neutral, it doesn't have any charge, so it's going to be 13 minus 0. So therefore 13 electrons. Now for the ion, it's going to be 13 minus the charge of 3. 13 minus 3 is 10. So the aluminum ion has 13 protons and 10 electrons. So we can see why the overall charge is positive 3 if you add these numbers. Now, one of the first quizzes that you may receive in your chemistry course is a quiz on identifying the elements, naming them, or being able to identify a property of a certain element. So I'm going to quiz you at this point. So let's start with naming elements. I'm going to give you a list of symbols, and I want you to write down the names of each of these elements. So what are the names of the 5 elements that you see here? H stands for hydrogen, C is carbon, Ne is neon, N is nitrogen, Si is silicon. Try these. Feel free to pause the video as you write the names of these elements. F stands for fluorine, S is sulfur, Na is sodium, K is potassium, Fe is iron. P is phosphorus, Co is cobalt, Cu is copper, Ge is germanium, Cl, chlorine. Ar is argon, Ca is calcium, Al is aluminum, Ni is nickel, Cr is chromium. Pd stands for palladium, Au is gold, Ag is silver, Pt is platinum, Hg is mercury, and Pb is lead. Sn is tin, Sb is antimony, He is helium, Li is lithium, Mg is magnesium, Mn is manganese. So let's try some more examples. Okay, I think that's good enough. Go ahead and name these elements. Pause the video, try it, and then unpause it when you're ready. Be is beryllium, Rb is rubidium, Ba is barium, Se is selenium, I is iodine, Kr is krypton, Xe is xenon, Br is bromine, AS arsenic, V is vanadium, W tungsten, CS cesium, RN radon, GA gallium, B is for boron, N is for nitrogen, O is for oxygen, GE is germanium, U is uranium, ZN zinc, CD cadmium, TI titanium. And watch out for TL, that's thallium. Now sometimes you might be quizzed on other questions relating to the elements. So let's say if I give you a list of elements: phosphorus, selenium, manganese, chlorine, and krypton. If I ask you which of these elements conducts electricity, which element would you select? The correct answer is manganese. Manganese is a metal. Metals conduct electricity. The other four elements are nonmetals. They're insulators. They do not conduct electricity. Now, which of the following elements contains two valence electrons? Is it potassium, calcium, gallium, chlorine, or sulfur? So let's find the number of valence electrons that each of these elements contain. Potassium is in group 1 of the periodic table. It's in the first column, so it only has one valence electron. Calcium is in group 2, so it has two valence electrons. Gallium is in 3A, or 13. It has 3 valence electrons. Chlorine has 7. Sulfur has 6. So the answer is calcium. Now let's say if we have chromium, strontium, sulfur, gallium, and silicon. Which of these elements is most likely to form a negatively charged ion, also known as an anion? Is it chromium? Is it sulfur? Is it gallium? Which one is it? So let's look at the charges that these elements like to form. Strontium is in group 2, so it likes to form a +2 charge. Gallium is in group 3A, so it likes to form a +3 charge. All of the metals typically form positive charges. Nonmetals form negative charges, so we're really looking for the nonmetal. Chromium is a transition metal, and transition metals, they could form multiple charges. Chromium could be +2. Sometimes it could be in the +3 oxidation state, but it's not going to be chromium. Silicon is a metalloid, and typically silicon usually forms positive charges as opposed to negative charges. Two common oxidation states are the +2 and the +4 oxidation state. Sulfur is a nonmetal, and nonmetals like to acquire electrons. So sulfur is going to form a -2 charge. It's in group 6A of the periodic table. Elements like oxygen, sulfur, selenium, they like to acquire 2 electrons to form a -2 charge. So now let's try another question. So let's say if you're given the following elements: bromine, selenium, germanium, potassium, magnesium, cobalt, and uranium. So here's the first question. Which of the following elements are considered to be metals? Circle all of the elements that are metals. So potassium, magnesium, cobalt, and uranium are classified as metals. Now, which ones are nonmetals? bromine and selenium are nonmetals. Ge, germanium, is the metalloid. Now, out of the elements listed, which one is an alkali metal? The only alkali metal that we have is potassium. Now, which one is an alkaline earth metal? The alkaline earth metals are found in the second column of the periodic table. And so magnesium is an alkaline earth metal. Now, which one is a transition metal? And which one is an inner transition metal? Cobalt is a transition metal, but uranium is an inner transition metal. Uranium is part of the actinide series. Now, which element represents a halogen? And which one is a chalcogen? Bromine is a halogen, and selenium is a chalcogen. Which of these elements is the most reactive metal? The most reactive metal includes the alkali metals, so that would be potassium. Which element represents the most reactive nonmetal? The most reactive nonmetal is the halogen, so that's going to be bromine. And which of these elements do you think is radioactive? The one that's most likely to be radioactive is the heaviest one, which is usually the inner transition metals. The most heaviest element that we have here is uranium. It has the highest atomic number. Elements with very high atomic numbers, typically like 90 and above, most of them are usually radioactive. So a lot of the elements that you see in the actinide series, most of those elements are radioactive, and uranium is one of them. Now, which of these elements is chemically inert, very stable? Is it phosphorus, nickel, chlorine, argon, or carbon? The one that's most stable is the noble gas, argon. Noble gases are chemically inert. It's very, very difficult for them to participate in a chemical reaction. You need something very, very reactive like fluorine to make these elements react, but for the most part, they're chemically inert. Now, which of these elements wants to give away electrons? The elements that want to give away electrons are the metals. The only metal that we have here in this list is nickel, which is a transition metal. So all metals, they like to give away electrons rather than receive electrons. Now, which of the following elements can conduct electricity? So we know that metals will always conduct electricity, so nickel is one of them. The rest are nonmetals. Most nonmetals, as we mentioned before, do not conduct electricity. However, there is one exception in this list, and that exception is carbon. Carbon has many different forms, or allotropes. Two common forms of carbon are diamond and graphite. A diamond does not conduct electricity. However, diamond is an excellent conductor of heat. Graphite, on the other hand, because of its structure, graphite is one of those rare nonmetals that actually do conduct electricity. So the graphite form of carbon and nickel can conduct electricity. Now, you need to be familiar with the elements and their physical states. You need to know the 7 diatomic elements. Hydrogen is diatomic. Nitrogen is a diatomic molecule. The same is true for oxygen, fluorine, chlorine, bromine, and iodine. So these exist as diatomic molecules. At room temperature, hydrogen is a gas, nitrogen is a gas, and oxygen is a gas. Fluorine is also a gas, and chlorine is a gas. Bromine is a red liquid, and iodine is a purple solid at room temperature. Now, there's some other elements that you need to be aware of. Most metals are solid at room temperature. However, mercury is one of those rare metals that's a liquid at room temperature. Another element of interest is gallium. At room temperature, at about 25 degrees Celsius, gallium is a solid. However, if you raise the temperature slightly to around 30 degrees Celsius, gallium will begin to melt into a liquid. In fact, if you put it in your hand, the heat from your hand can cause gallium to melt into a liquid. Now, this is all I have for this video. Hopefully you found it to be beneficial. So thanks for watching and have a great day.